All right, today we're going to talk about defining thermal equilibrium. We're going to look at when we add two objects of different temperatures that they're going to reach an equilibrium or a balance. We're also going to talk about how objects in the same room will come to thermal equilibrium. So think about the video that we watched about the guy that was going around and asking people what the temperature felt like of a paper book and a metal hard drive. Most people said that they felt like the hard drive was colder than the paper book. But remember, we discovered through watching that video that objects that are in the same room or the same area are going to come to equilibrium regardless of the type of material that they're made from. And so let's watch a little portion of this video clip.
F 108.9.
And the temperature of the tin?
118.6, but dropping.
Over here?
108.1.
So we have, what would you say about the temperature of the cake and the tin?
Pretty close. Much closer than I expected.
They're quite similar. They're both around 110 Celsius.
That's my point, is that the tin and the cake are the same temperature. But the tin is going to conduct heat to your hand much faster than the cake. So the tin would burn you, but the cake would not.
Okay.
So remember, the point that he was trying to make here was that even though the objects are the same temperature, they feel different to your hand because metal is going to conduct heat faster than an insulator like paper. Then we talked about when you add two objects of differing temperatures that those two objects will come to thermal equilibrium. In this example, you can see the hot object is 100 degrees Celsius and the cold object is 0 degrees Celsius. And when they are allowed to mix, both temperatures are now at 50 degrees Celsius. So the hot object decreased by 50 degrees and the cold object increased by 50 degrees. So we can see that that 50 degrees from the hot object got transferred to the cold object. So let's try a problem. Using your calculator, add 46.3 and 20.8. When we take these two different cups and we combine them, let's see what the new temperature is going to be. We have to calculate the average. So do that right now on your calculator. Okay, that should have been 67.1. Then to get the average, we have to divide it by 2, and we would get 33.5. So the new temperature in the cup would be about 33.5 degrees Celsius. If you need more practice with this, we've got some practice problems that you can do. Come up and ask your teacher. And when you feel comfortable with this, come get an exit slip and take the retest.